All right, we are back with another video. This time we're going to be talking about broadcast receivers and like broadcast intents in the Android landscape. This is going to be a pretty quick video because then again it's around the holiday time and I am uh, struggling to get the time to make these videos on the schedule that I'm trying to make them. So without any further yapping, let's go ahead and just start discussing. So first, what is a broadcast receiver? Android applications can send and receive broadcast messages from both the operating system and other Android applications. An example of this would be like plugging in the phone, turning on airplane mode. Different apps will act differently if different applications will act differently if the screen is locked, things like that. It'll make a little bit more sense in a moment. But let's talk about how registering a broadcast receiver works, because typically you can send a broadcast and you can receive it. But let's talk about it. So you can either do it statically or dynamically. Statically, it'll be in the Android manifest just like this, and it's incredibly similar to an intent. You even have an intent filter. So you say, hey, anything with this intent filter will get routed to my receiver. Um, and if you're doing it dynamically within some kind of activity or some kind of class, typically named after that receiver, you would classify it like this. Here's my receiver, and then here's the intent filter for this receiver. So anything being sent, typically any broadcast with this intent filter being sent, will get routed to my receiver, and then whatever happens to it happens. When you send a broadcast, any receivers who match the intent filter will then execute whatever logic they have mapped to it. And we'll practice really quick what that might look like. So um, here is an activity for, I believe, this might actually be a bad example because there's two halves of this. So basically, this is for the flag 16 activity, which is not exported, but yeah, the flag 16 receiver here is exported and it's enabled. So um, I think we have a duplicate. Yeah, okay, we have a duplicate of this on the next slide here. So this class receives an incoming intent right here, or an incoming context and intent, um, which will, let's see here. It'll call the success method if the get string extra flag is equal to this. So again, right, like this doesn't really seem that different from when we were practicing with intents. And that's true, it's really not in this context. We can again just create an intent, add specify where we want it to go, in this case, the flag 16 receiver, and then add this extra so that it fulfills this condition and send it along. But we're sending it as a broadcast. So that sending it as a broadcast, all it's doing is making it so that it can be received inside of a broadcast receiver, which really doesn't sound like a huge deal. It sounds very, very similar to intents. And that's, from what I can tell, kind of because it is. Um, it's just that the use cases for broadcast receivers might be a little bit more sensitive in some cases, or maybe not so sensitive depending on the application. So again, we would set this to our on click our button, boom, we get the flag. Makes perfect sense. Something to include about something I touched on at the very beginning is system event broadcasts. So regular applications can't send like system level broadcasts, and for obvious reasons, right? A good example is, let's say, airplane mode's kind of a goofy example because whoever uses, airplane mode's just not that common to be used, from what I can tell. A better example might be, let's say, like using the lock screen, for example. It makes sense to notify an app whether or not the screen is locked. So like let's say you have an application like a banking app. If the screen is locked, you wouldn't want the banking app to be able to continue displaying information, even if it doesn't really make sense for it to be, like, oh, how could it be displayed if the screen is locked? That kind of thing. Um, it shouldn't really matter, but what you would, you know, it would stink if you installed an app on your phone that could keep telling other apps that the screen is locked, and then those other apps might be performing those kind of actions. Or apps that will give you a warning if your battery's low, or apps that act differently if headphones are plugged in, things like that. Those are system event broadcasts, and typical like applications that are running on the system that are not the operating system can't send those types of broadcasts. Um, Intercepting and redirecting these broadcasts, and I might as well just call them broadcast intents because they're very similar to intents, operates the same way. So like lots of the threat surface strategies we used for normal activities can be applied to broadcast receivers. So um, think about like an activity that takes an intent as an input and then sends it out as a broadcast after modifying it. In this case, an attacker could control that broadcast intent. So again, like let's say the app sends an implicit intent, a malicious app declared in its manifest that it can handle that intent, and the intent is controlled by the malicious app. Most of these broadcasts, as you'll see, will have are basically just wrappers for intents. So all it really changes is how we're talking about what we're doing. So let's talk about I think, or do I not have it written? Anyway, I think this is hijacking a broadcast intent. So here's our flag 18 activity, and this one's a little bit tricky because I kind of circled some things that aren't as relevant as they need to be. But you can see on create, it adds this new intent that has this free flag action. It puts this flag extra in here. It adds the flag labeled 8, which I don't have written down in my notes. But what's important is it sends it as an ordered broadcast. It has this intent, so everything in here tucked away. It has null, which just specifies that there's no permissions attached to this. And then it creates a new broadcast receiver, and that's where this is going to be passing through. So again, all this intent is going in here, and it's being sent as an ordered broadcast. An ordered broadcast just means that it's sending to one receiver at a time. Now, down here on this broadcast receiver, it takes the string. Let's see. It takes the context and the incoming intent. So this is some other intent when it receives something back. And then it takes the result data and writes it to a string. It takes the result extras and writes them to a bundle. You can see the result extras are and the result data are all output as part of this log. Same with the result code. And the only thing we need to do to get success triggered is make sure that our result code isn't 0. But it also would make sense to make sure that our result data and result extras have something in there, so that these logs perform the way that they're expected to, and that there's no other issues in executing it. So I mean, aside from that, right? What I'm saying is all we need to do is have a result code that's not 0 and send that over. So this activity is just designed to handle. Well, I mean, it's designed to send an intent um, in the form of this like ordered broadcast, and then it's sent to receive something. So if we look at the next slide, we can register whenever you type in, at least in Android Studio, this register receiver, new broadcast receiver. Everything outside these curly braces is not filled in, but this override and public void, this is created by default. So all we need to do is make this flag string, just so we have something to send over. And then I'm just logging flag 18 is whatever this flag gets sent back as. And then I'm saying, hey, in the result, because again, right, it's looking for a result code that's not 0. Result code's 42. The value, where is it? I think this is the result extras. We set its test. Oops. Yeah, the extras, we set its test. And then we create a new bundle just to send it. And then we clarify our intent filter is free flag because that matches where this intent that's going out is going to go. And then we have to specify that this receiver is exported. So when you click on the flag 18 button, it sends an intent with this action, ends up here. It sends us, this put extra flag. We reply with the same, oh, here's get this flag extra and output it, and then set this result, test, new bundle, etc. And then in your own logs, you should be able to see the flag. Pretty straightforward example. This next one is going to be sending and receiving a broadcast. So here you can see there's what is it? This flag secret, and that is called again. What is it? Yeah, this one's even more straightforward if I remember right. So if flag equals flag secret, so if you send an intent to this receiver that has this string inside the flag extra, then it'll call success and you get the flag. The only caveat being that it sends this back to you, the success method sends it back as a bundle, so you have to do some unpacking of it. So this is just sending the correct intent, right? We create a new intent, send it to flag 17 receiver, make sure the extra is called flag and includes this data. Send it as an ordered broadcast, and then for our receiver, so that we can get this flag back, we need to go through a bundle. The easiest way that I found to understand bundles by reading the documentation a little bit and asking a few LLMs to kind of explain it to me as if I was a toddler. Bundles, at least in this case, kind of act like a key value pair. And so you, if you want to get like these result extras, or um, if you want these results, um, in the form of this bundle that's getting sent to you, that has the flag like 17 activity log and everything here, you will need to take it apart. So that's what this logic does. So replace everything in here with this. We create a new bundle. Then we make it just get the extras that are coming in. We make a string called result data, and then make sure that we're just extracting the key value pairs and iterating through them. So the output will look something like this. We have a key called success that's equal to true. We have a key called flag that's equal to the flag. And then we have data, which is output here is just the result data, um, which is like so. So again, a little bit more tedious. I think you can actually get around this by just looking at the logs from all applications and it'll log it for you, but this is another way to solve it if for whatever reason you wouldn't be able to do that. Next, we're going to talk about widgets. So Android can have widgets on the home screen, as you might know. iOS can also have these. They're not terribly new. A weather app is a good example, or in this example, I'm talking about like tracking type apps. When I say tracking, like this is a fitness tracker. If you have like a Fitbit, a Whoop, an Apple Watch, what's the other one? A Garmin, I think, is another popular one. They probably have widgets that'll show you some of your key metrics for whatever your activities are. And these are typically implemented as broadcast receivers because the function, right, is let's say you have some wearable fitness device. It sends data to the application. So like you have this device here, sends data to the application. The application sends that data to the widget every so often and updates it. Pretty straightforward. And a good way to do that would be with broadcast receivers because their function is to receive information from the app and display it. But you could also send that data to other apps as well, either from the Whoop app or from some other thing. So that's why I'm using this as an example. These widget interfaces kind of act as a wrapper around a broadcast receiver to update widget data in the background. They can also perform button presses. So think of like Spotify or like some other music player, right? Where your button presses would act as a pending intent that's being sent to the main application. So even though the widget is technically a part of the app that it came from, when it's running on the home screen, it uses broadcasts to communicate back to the app, just so you don't have to like open it again, something like that. And it's usually done with this app widget provider. This is how you define it in the like Android manifest. And we'll see an example of it here, of course, in the hextree.io attack surface app. So we can add a home screen widget. This I don't have included here the logic for the activity itself because the activity basically just shows you the logic for showing you this, right? Um, and that's most of what like I think it's update widget, which is another method that if you scroll down in this screenshot or scroll up, I forget, the update widget method is there, and that's basically what just tells this app what the flags are. Anyway, um, so that update app widget sets up the UI, configures the button, etc., and then sends this intent called the app widget update, um, which contains this app widget IDs, etc., etc. And the on receive method, where's that? Yeah, right here. Again, it's ready to take an incoming intent in the form of this app widget update. So this is like the intent that's coming back from the widget. You can think of it that way. And then all it's meant to do really is just, oh, if action is null and this is here, et cetera, then just return. Don't do anything different. But then for the flag, if our I is equal to this, which is our like app widget max height, and then app widget min height are equal to these specific numbers, it'll call success. And calling success will just straight up send us the flag. So all we need to do is send an intent to the application, pretending to be the widget, which it really isn't that tough because all we need to do is have the action set. It's not using any authentication. To declare these two numbers, and then I'm pretty sure that's all we need to do. The only caveat being, yeah, these are bundle extras, not intent extras. So make a new bundle, or make a new intent, make a new bundle, add these specified values to the bundle as integers. So here's the name of the integer, here's the integer. Set the action to app widget update, again, as we see it here. Put the extra app widget options as this bundle that we created. We can see that. Where is it? App widget options right here. That's the name of the bundle that it's expecting. And then we set the class name again. This is going to the flag 19 widget. Send the broadcast, and then you'll see a little success message and go to the app and read the flag. Pretty straightforward, not that complicated. The notification system is pretty similar to this too. You create notifications with the notification builder class. You provide, a title, a clock, some text, an icon, and then these actions that you can have inside your notifications will, how do I describe it? These can act as, what's the word I'm looking for? These act a lot like pending intents. Whoops, let me go back. These act like pending intents. So these will send like a pending intent to the application. In this case, if it's like an alarm clock, press the snooze button, sends a pending intent to the application that, snoozes it, whatever. What kind of vulnerabilities can we see in this? Well, if the broadcast receiver for these actions performed by the notification are exposed, we can either impersonate the button press, or we could, if it's an implicit broadcast intent going from the button, we could impersonate the app that's trying to, or, we could impersonate the receiver, or we could impersonate the button press itself. So first, we'll talk about impersonating the button press. So when you press this button, you'll see this in your logcat output. This is the action that's sent along with the pending intent that this sends. If we look at the flag 20 receiver, you can see it looks for this this give flag boolean, and if it's set to true, it'll go through and resolve success. So all we need to do is create an intent, right, that has this get flag action set, has give flag set to true, and then we'll get it as long as we send it as a broadcast, because again, this is a broadcast receiver. Intent, set action, put extra, boom, it's done. Pretty straightforward. We're just pretending to be the button press that is an intent. So it's not that complicated. Hijacking a notification button. This is very, very similar, but instead, what we're going to be doing here is like the logic is fairly similar, but the only difference being last time it was get flag, now it's give flag. And we're just pretending to be the receiver so that when that button is pressed, it should come to our application and we can output something. This time, we're hijacking the intent on its way to the app. As our intent filter matches this give flag thing, when we press the notification button, it'll send it to our app. So again, we make a new receiver. That's all pretty straightforward. It's exported. We create a flag or a string called flag that'll pull the flag from the logic and then print it out for us. Here's the logic. Here's it working when you're pressing that notification button. It's about all there really is to it. I couldn't find any good CTF examples, so we're going to have to go with a 9-year-old bug on HackerOne, because so many of these vulnerabilities either seem to be in private vulnerability research programs, or they're just not public or not disclosed, which seems to be the trend. I'm guessing just because the mobile attack surface, albeit it's limited in impact, it's still huge, right? Everybody's got, not everybody, but a lot of people got a smartphone. The majority of people got a smartphone. There's billions and billions of smartphones out and about being used every single day. So, um, here's an example of a bug from 9 years ago that's still somewhat relevant because you'll still find broadcast receivers or broadcasts that are sent with an implicit intent. So here's an example, right? Um, this is the Shopify app, which if you don't know about Shopify, it's a way that you can create online shopping websites and mess with them, and they have an Android app. In this case, when you log in to the Shopify client, um, I think it says somewhere in here, um, yeah, when you log in, it sends a broadcast, but it's not protected by any permission. So you can stick up your app basically just like we did this last time by pretending to be some other um, application by specifying our intent filter, and then you can just catch um, any of these incoming what do you call it? Uh, just catch these incoming broadcasts. So that's exactly what this researcher did. He set up his malicious application to catch those, and then if you look at the logs, you can see the access token getting leaked, among with a few other ones that are listed here in the impact. So again, these aren't made up. These aren't really obscure. I mean, Android and mobile testing in general, you could argue is obscure, but um, who cares? Anyway, here's an example. In conclusion, we talked about um, kind of not attacking, but well, you could argue it's attacking, but manipulating data that's going to exported broadcast receivers, hijacking broadcasts that are using implicit intents, returning arbitrary data to any of these exposed receivers, so just regular process communication, and then performing basically those same things, intercepting broadcasts that are going to widgets and notifications, and impersonating a widget or impersonating a notification so that we could perform some malicious action. That's all we've got for today. Pretty short video. Thanks for tuning in. Have a good one.